All right, we are going to do a couple examples together before you try your quiz again to help you answer the questions about solving quadratics. So we've been talking about a couple different methods to solve a quadratic. We could use the zero product property when the quadratic is in factored form. We could use our square root method if it's in graphing form, and we have been practicing the quadratic formula as well. So let's see a couple different methods in action here. The first I'm going to use is the zero product property. So I'm going to try that on this quadratic. Let's see if it factors nicely. So my first job here is going to be to create my diamond, identify what A, B, and C are. So here's my diamond with the dashed line. I want to put A times C up top, so that would be negative 36. B on the bottom, and then A goes under the dotted line. So I'm asking myself, what multiplies to a negative 36 but adds to a 5? So because I'm multiplying to a negative number, one of my factors has to be negative. Right? If the product is negative, one of the factors is negative. So I'm going to remind myself with a little negative sign there. And I want it to add to a positive. So that means the bigger number is going to be positive. So I'll have one positive, one negative answer here. So let's see, factors of negative 36. So you should be making your list 1 times 36, 2 times 18. Let's kind of go through some of those, and you'll see that the factors that will get it done is negative 4 and 9. Right, negative 4 times 9 is negative 36. Negative 4 plus 9 is 5. So my next step is to simplify these fractions. So negative 4 divided by 6, how can I simplify that? I can divide top and bottom by 2, and I get that fraction. And then 9 divided by 6, I can divide top and bottom by 3, and I get 3 halves. So now let's put this in factored form. So n minus 2/3, n plus 3 over 2, and that's equal to 0. And now I slide it forward, slide the denominator. And now I'm ready to use the zero product property, which tells me if I have two things being multiplied and the product is 0, one of those factors has to be 0. So let's solve this for n. So I added 2 to both sides, and I get my first x-intercept to be 2/3. Let's solve this one. My second x-intercept is negative 3 over 2. So these would be your final answers, right? And like I predicted, one's positive, one's negative. And notice, aren't they just the opposite of my reduced fractions? So that's another shortcut you can use, is notice it's just going to be the opposite. So that's a great tool to use as well. Let's try another one. So again, I'm going to try to use the zero product property. Identify my A, B, and C. So 16 up top. So this time I'm multiplying to a positive, but I'm adding to a negative. So the only way to add two numbers and get a sum that's negative, but multiply to a positive number, that tells me they're both negative, right? A negative times a negative is a positive, and a negative plus a negative number would give you an even bigger negative number. So this looks like we're in pretty good shape so far. And let's think to ourselves, how do I multiply to 16, but add to a add to a negative 17? And that would just be negative 1 times negative 16, right? Then our next step is to look at these. Negative 1 over 4. There's no way for me to reduce that. And negative 16 divided by 4, that just equals negative 4. So my next step is to slide the denominator. Here there's, you could give yourself a 1 to slide, but that's not necessary. Oops, I forgot my 4 here. So I get 4n minus 1 and minus 4. And now I can use the zero product property, which tells me if my product is 0, one of these has to be equal to 0. So those are my two answers, my two x-intercepts. Here they are. And again, notice, aren't they just the opposites of these values? Yeah. So really, when you create your diamond, you're finding your x-intercepts. They're just the opposite. So that's a great way to make sure you solved these correctly. So let's try this one now. So let's see what kind of pattern I have this time. Looks like I'm multiplying to a positive number again and adding to a negative. The only way to multiply to a positive but add to a negative is if I'm multiplying two negative things together and adding two negative things together. So I know that they're both going to be negative. And negative 6 times negative 6, that gives me 36. And negative 6 plus negative 6 is negative 12. My a value, I forgot to put under my dotted line, is just 1. So that means I'm not going to have to slide, right? Negative 6 divided by 1, that just gives me negative 6 for both. So when a is 1, you're not going to have to slide. So I have two of the same factor this time. So I just get x is 6, and I'll just show you it both times, but we know it's going to be the same answer. So what that tells us is in this case, I only have one x-intercept, and it's at 6, 0. That's my only x-intercept. So this is one of those parabolas that only crosses the x-axis at one place. So these are a couple examples using the zero product property. Let's do one seeing it already factored out, right? So this looks a little tricky and sometimes it tricks you guys up, but this is actually easier because I don't need to identify A, B, and C. I can't figure them out. It's already factored, so this is already done. I've already done the diamond problem. Now I can just set each equal to 0. I already know what my factors are. This is half the work's already done. So we just have to solve these two equations. And I get my first x-intercept to be at negative 2 over 9. And I get my second x-intercept to be at 1/3. So this one is a little different. It's already in factored form, right? We don't have to go through the work of creating our diamond to get to this point. We jumped ahead in this example. The last one I'd like to do with you is an example of the quadratic formula. So this is the last one I'll walk you through. When we solve quadratics, the first thing we need to look for, though, is we need it set equal to 0. So right away, I'm going to subtract 1 from both sides so that I can clearly see my a, b, and c. Now, 1x and 1, 5x squared and 1, those are not like terms. We have to have the same variable and the same exponent, so I just write it like this. There's nothing I can combine. So that tells me my a is 5, my b is -1, and my c is -1. Let's just take a moment to try to factor it, and let's see what happens. So 5 times -1 goes up top. I want it to add to a -1, and under the dotted line would go a 5. So already I'm getting kind of nervous because how do I multiply to -5? It's either 1 times -5 or -1 times 5, right? 5 is prime, so that's really the only way to do it. And neither of those add to -1. So this is not going to be factorable traditionally, but we've been talking about in class that doesn't necessarily mean that it's impossible to solve. It just means that the x-intercepts are most likely maybe a decimal that we can't get an integer factor for. So we want to use the quadratic formula. So I'm going to first write it out just in case you forgot it. So all we're going to do now is plug in my values for a, b, and c. So -b here, that would be -1, so that would give me a positive, right? And then plus or minus square root of. Awesome. So then I'm going to clean this up a little bit. We can put this in our calculator, right? This would just be -1 squared. That would be 1. -4 times 5 times -1 would give me a plus 20. All over 10. So it looks like I get so my exact answers would be x equals 1 plus root 21 divided by 10. One minus root 21 divided by 10. So that would be the answers in exact form. If you wanted these as a decimal, you would have to pop over to your calculator and put those in. Let's see if I can pull up mine and show you how to do that. Oop, it's going to take a moment to load up here. It's going to take a moment. So get out your calculator, try to put those into the calculator here. All right, so I want to go 1 plus root 21, and that's my numerator. I would just go right ahead and press enter there and then divide by 10, because if you do it all in one step, you might mess up the order of operations. So my first answer is about 0.56. So that's my rounded answer, is 0.56. And now let's figure out what my other answer is. So I'm just going to do 1 minus root 21 divided by 10. And I get -3.6. negative 0.36.